In this video, we frame addition, subtraction, multiplication, and division as functions. What really do we mean when we say addition? Can we think of addition as a function? Well, in some sense, addition has inputs and an output. What sort of inputs does addition have? Well, if I input 5 and 3 into the idea of addition, the function of addition, I get out 8. So I could write something like this. The sum of 5 and 3 is equal to 8. I could also use the letter D for a difference function and write something like this. The difference of 5 and 3 is 2. Here, given these two inputs, I take the first number and then I subtract the second number, and that's my output. I have a clearly defined process, a clearly defined machine for getting from my two inputs to my single output. And of course, I could similarly define a product and a quotient. The product of 5 and 3 is 15, and the quotient of 5 and 3 is 5/3. So if I take some sort of simple arithmetic like this, I can rewrite this as some sort of combination of functions. In particular, I could rewrite 4 minus 1 as a difference, and I could rewrite 5 times this number as a product. And finally, I could rewrite this addition as a sum. These parentheses match, these parentheses match, and these parentheses match. So this final line here is completely equivalent to this line I've written at the top. In particular, in order to compute this bottom line here, I would start from the innermost parentheses. I would compute the difference between 4 and 1. Then I would compute the product between 5 and that difference. And finally, I would compute the sum of 3 and that product. In each of these cases, my functions are structured in essentially the same way. They are what are called binary functions or binary operations. They receive two inputs and spit out a single output. I could write that S is a function which receives two real numbers as its inputs and gives out one real number as its output. So another kind of strange, fresh interpretation of how we might think of functions.